Hello, it's Mr. Lauer here. This is Simplifying Radical Expressions Part 2. I wanted to make a video to help those students who weren't here in class today, and also maybe the ones who were and that maybe need a few more examples. So last time we spoke, we were talking about simplifying radical expressions, and we were just using the rational exponent property to do that. This is going to be pretty similar. The difference here is that we have a bunch of radicals that are being multiplied. So remember that radicals are roots. Okay. There's a couple properties of radicals that will be helpful for us. So let me give you those properties really quick. All right, the first one has to do with multiplication. So if I have a root, and I'm just going to put an n here, so that can be any root, and I multiply that by another root with the same index number, what I can do is I can put both of these two factors in the same root. So it's still an nth root, but now I can just do a and b, or a times b, inside the radical. So that's a property of radical expressions. So in some of these, this is actually pretty easy process, right? So notice that the square root of 5 is already as simplified as it's going to be, and the square root of 3 is as well, because they're both prime numbers. So to multiply these, I just got the square root of 5 times 3, right, which would be the square root of 15. Notice that the index matches here. This is a 2 root and a 2 root. So if I had like the square root of 5 and I wanted to multiply that by the cube root of 3, I couldn't do that. That would be kind of different, so that's not going to work. But if the roots are the same, I can do this property. All right, so similar thing over here. The square root of 10 is already simplified as much as it's going to be, and the square root of 3 is as well. So when I multiply these two, I'm just going to get the square root of 30. Okay, so no big deal there. All right, number 3, when I multiply these two guys, I'm going to get the square root of 36. Okay. Now, we want to simplify as much as possible. These two guys are already as simple as they're going to get. The reason we know that is because if we look at 10, the factors of 10, we have a 2 and a 5. And so if we have a 2 and a 5 and a 3, and there's just one of each of them, there's no way that we're going to get any simpler. But in this case, we have a pair of 6's, right? 6 times 6 is 36. And we know that the square root of 36 is 6. So we can actually simplify that as well. All right, now number 4, there's a couple ways to go about this. So far this has been a pretty easy process. What's going to happen now, though, is if we multiply 20 times 15, we're going to get the square root of 300. And the square root of 300 is not simplified. We need to be able to simplify that, and we talked about how to do that last time. We basically break it into prime factors, and then we use the rational exponent property to rewrite it and then simplify the roots. So if we were going to simplify this, the first step that I would do is I would prime factor 300. I would take 300 and I would break it up into, let's say, 10 and 30. Okay. And then I can break this up into 5 and 2. And this is 5 and 6. Oh, sorry, 6 isn't prime. But 2 and 3 are prime. Okay. So when we look at this root here, what we have is the square root of 5 squared, and then we have 2 squared, and then we have 3. So 5 squared, 2 squared, and then 3 to the 1 power. Remember that this is the 2 root, so if we want to rewrite these as rational exponents, we're going to get 5 to the 2 over 2, 2 to the 2 over 2, and 3 to the 1 over 2. So when we simplify all these guys, zoom in a little bit, we're going to get 5 to the 1 power, because 2 over 2 is 1, 2 to the 1 power, because 2 over 2 is 1, and then we still have this 3 to the 1/2 power that we can't do anything with. So we convert it back into a root, right? This is the square root of 3 to the 1. This is the index, so we need a 2 root, and then 3 to the 1 power. So that'll be the square root of 3. We don't have to write the 2 or the 1. We know that that's a 2 root and a 1 power. So altogether we get 5 times 2, which is 10, root 3. Okay. Now, you might be thinking to yourself, hold on a second. you multiplied 20 times 15 to get 300, and then you factored 300. That kind of seems like we're going in circles because we multiplied and then we ended up factoring anyway. So one of the ways that we could have done this from the beginning is instead of multiplying 20 times 15 to get 300, we could have simplified this from the get-go, and that could have made our lives a little bit easier. So let's take a look at what that would look like. So if I broke this down as 10 and 2, and then 5 and 2, right? I have a 5 and a 2 and a 2. And then this guy is a 5, and this guy is a 5 and a 3. So I still have all the same factors, right? I have 5, 2, 2, 5, and 3, right? 5, 2, 2, 5, and 3. It's still the same factors, whether I multiply them here or whether I factor them from the beginning. So there's more than one way to go about this. I want to show you a couple more, and I'll do a few where I factor at the beginning. It may not be as advantageous to multiply these first and factor it later. You may want to do it the other way around. Let's take a look at a few more. All right. In this case, let's factor first. Okay, now I could do square root of 5 times square root of 10 equals square root of 50, but again, I'm just going to have to factor that. So instead of doing that, let's just factor from the beginning. So this is going to be, this is already factored, that's prime, right? And this is 5 and 2. Okay, so altogether, I have square root of 5 to the 1 times the square root of 5 to the 1 times 2 to the 1. Okay, if I turn these into rational exponents, I get 5 to the 1/2, because this is the 2 root, times 5 to the 1/2, again this is a 2 root, and 2 to the 1/2. The advantage of doing that now is that I can see that I have 5 and 5, so the same base here. And if I have the same base, I can add these exponents. So now I have 5 to the 1/2 plus 1/2, and 1/2 plus 1/2 is 1. So I have 5 to the 1, 2 to the 1/2 power. And now I can turn this back into a root. So this is a regular 5. This is a square root of 2. So I have 5 square root 2. Okay, so there's kind of a compare and contrast. This one, I multiplied the numbers first, and then, I multiplied the numbers first and then factored that big number. Here, I decided, well, if I'm just going to factor anyway, I'm not going to multiply them. I'm going to factor them first, and then I'm going to simplify from there when I put them all together. So those are a couple different options for you. All right, let's take a look at number 7. Now, 7, for some reason, didn't make it onto the answer key. So we can try a couple different ways. All right, the first thing we can do is just see what 24 times 6 is. And it turns out, if you didn't know, that that's 144. So this is just the square root of 144, which comes out to a 12. So that's kind of nice. Now, if you didn't know that that was going to come out nice, then you probably would have done it a different way. You may have factored these first. And if that's the case, then you would have gotten maybe a 3 and an 8, which is a 4 and a 2, which is a 2 and a 2. And this guy is a 2 and a 3. Okay, so when we have all of our prime factors here, we have what I'm going to do here is I'm factored all these, and then I'm going to write them as rational exponents. So let's start with the root. I got 3 to the 1 times 2 to the 3rd, and then I have times the square root of 2 to the 1, and then 3 to the 1. Okay, so remember these are root 2. So what I can do is I can write this as 3 to the 1/2, 2 to the 3/2. Sorry, that's 3/2. And then over here, I have 2 to the 1/2, and then 3 to the 1/2. Okay. Now notice that I have similar bases, so I have 2 and 2, right? So I can add the exponents. 3 over 2 plus 1 over 2 is 4 over 2. So I have 2 to the 4 over 2 power. 3 to the 1/2 times 3 to the 1/2, if I add the exponents there, I'm going to get 3 to the 2/2. So 4/2 is 2, so this is 2 to the 2. 2 halves is 1, so I have 3 to the 1. So that's 2 squared times 3 to the 1, or 4 times 1, which is equal to 12. So there's more than one strategy here, and that's what makes this this topic, it's not difficult, it's just that there's multiple ways of going through it. And so when I have students asking, well, what about this way and what about this way? Yeah, there's lots of ways you can do it, and you kind of have to just get some experience and practice until you find the ways that work the best. All right, let's take a look at number 8. All right, now if you're thinking ahead, 50 times 2 is 100, right? So this is square root of 100, which we know is 10. Awesome, so we could do it that way. We could have also, simplified this and then multiplied. So that's an option as well. That's pretty much what you're going to be doing on this assignment. You're just going to be, it's almost like simplifying radical expressions again. It's just that we have multiplication happening here, and the process is very, very similar. Let's look at another one that I think is incorrect on the answer key. So I just want to make sure that everybody has this one. Okay. In this problem here, we want to start by, again, writing everything as squares. So this is pretty easy to factor. 4 is 2 times 2, 4 is 2 times 2. So this would be 5 times the 4th root of 2 times 2, sorry, start over. 5 times the 4th root of 2 squared x to the 5th. Okay, on the other side, I have the 4th root of 2 squared x to the 1. If I take this and I change them to rational exponents, I have just a regular 5 out here, and then I have 2 to the 2/4, x to the 5/4, 2 to the 2/4 again, and then x to the 1/4. All right, so I look for my guys that have the same base. So here, these two guys have the same base. So I have a 2 and a 2. I'm just going to add the exponents here. 2/4 plus 2/4 is going to be 4/4. So I have this 5, and then I have 2 to the 4/4. Just adding the exponents there. And then I have x to the 6/4. So 5/4 plus 1/4 is going to be x to the 6/4. All right, so now we'll simplify. This is a regular 5. This is now a 2 to the 1 power, which is a regular 2. And this is going to come out as 1 2/4, or 1 1/2. 6/4 is the same as 1 1/2. 3 halves are 1 1/2. So I have x to the 1 and x to the 1/2. Remember, if we have a mixed number, we need to split it up. So a regular 5, a regular 2, a regular x, and then an x to the 1/2 power. So altogether, I have 5 times 2, which is 10, and then times x, so 10x. And then I'm going to rewrite the x to the 1/2, that's the square root of x. Now in the answer key, it has a 4 here and a 2 here. And I think the reason why is if you have 6/4, that's 1 2/4. And so 2/4, you'd have a 4 here and a 2 here, but you can actually simplify that more, which is what we would want to do. So on 17, this is actually what you want right here. Okay, and that's an example of one with a variable. Okay, let me show you one more method that people have been kind of asking me about, which is also valid and also something they can use. If you don't like this method, or if you don't really understand how it works, that's okay. You can use the other method and it works just fine. But like I said, there's several ways of getting to the correct answer here. Let's take a look at, let's do some evens here for you. So let's take a look at 14. Okay, so we still want to prime factor this. So this is the square root of 2 to the 1 times 3 to the 1 times m to the 2. Okay, we're going to multiply that by the factors of 10, which would be 2 to the 1, 5 to the 1, m squared. Okay, now what we could do with these is we could put them all in the same root if we wanted to. And so we have the square root of 2 squared. Now let's keep in mind we have 2 to the 1 and 2 to the 1. So if I have 2 to the 1 and 2 to the 1, that's going to give me 2 squared. I have a 3 to the 1, and I have a 5 to the 1, and I have an m squared, and I have an m squared. So 2 and 2, 3 and 5, m squared and m squared. Okay, now the square root is the inverse of square, right? So I'm going to put a little 2 there. The squared is the inverse of square, so if I find something squared, the square and the square root will cancel each other out. So let's rewrite this one more time. And let's just put the 2's together. So I have the square root of 2 squared, because 2 to the 1 times 2 to the 1. And then I have 3 to the 1, and then I have 5 to the 1, and then I have m squared, and then I have m squared. Okay? So the square root is the inverse of square. Oh, sorry. You can't see that. So if I see something squared, I can kind of cancel those out. So I have a squared and a square root, so those are going to cancel each other out, which means I'm just going to get a regular 2. Okay, I also have the square root of m squared, which is m, and I have the square root of m squared again, which is another m. Okay, and then I can't take the square root of 3 to the 1, and I can't take the square root of 3 to the 5, so I have a 3 times a 5 still in the root. So everything that had a squared, 2m, I'm able to take the square root of, and so I can put it on the outside of the root. So what this is going to be altogether is 2m squared times the square root of 15. Okay. Now you could have gotten that exact same answer using rational exponents, because if you think about it, this will be 2 to the 2 over 2. Well, 2 over 2 is 1, so there's 2 to the 1 power, right? M to the 2 over 2, that's just m to the 1. M to the 2 over 2, that's just m to the 1. And then I have 3 to the 1 half, that's the square root of 3, and 5 to the 1 half, that's the square root of 5. So another way of going about this is to look for things that are squared, or to group things that are squared, so that we can take the square root of them. If you write it out with fractions, you'll see that exact same thing happening, and you'll still get the same exact answer. All right, let's do one more with that method. Okay, number 15. So if we prime factor this, we have the square root of 2 times 5 times r. And that's 2 to the 1, 5 to the 1, r to the 1. Okay, we're going to multiply that by 2 times 3 times r to the third. Okay, and again, this is 2 to the 1, 3 to the 1, and then r to the third power. Okay, if I want to, I can group all of those things under the square root. Okay, so I would have 2 times 2 times 3 times 5, almost pretty similar to what we had over here on the other side. And then we have times r to the third. Okay, this is actually very, very similar to the last one. Okay, so if we kind of group things in groups of, or powers of 2, I have the square root of 2 squared times 3 times 5. Now, this here is going to be r to the 1 and r to the 3, so that's together is r to the 4, r to the 4th power. And if I want to, I could change that to r squared and r squared. It doesn't really matter. Either way, I should have 4 r's. So there's 1, 2, 3, 4, or 1, 2, 3, 4. And I'm just grouping it in a way that allows me to take square roots. So the square root of 2 squared is 2. Okay, the square root of 3 is the square root of 3. I can't do anything there. The square root of 5 is the square root of 5. I can't do anything there. But the square root of r squared is r, and the square root of r squared is another r. Okay, the things that I couldn't take the square root of are 3, or 3 to the 1, and 5. Okay, so when all is said and done, I have 2 times r squared times the square root of 15. So almost identical to the last one. All right. Now again, you can totally use fractional exponents here, or rational exponents. Remember, this is a root 2. So this will give me 2 to the 2 over 2, 3 to the 1 over 2, 5 to the 1 over 2, and then I would have like r to the 2 over 2, r to the 2 over 2. And you can see that this is 2 to the 1, r to the 1, r to the 1. There's my 2, r, and r. This is my square root of 3 and my square root of 5. So the rational exponent property will work out just fine for you. Some people don't have a hard time with this, seeing the inverse operations, the square root of 2 and the 2 squared undoing each other, the square root and the r squared undoing each other. So if you're having a hard time seeing that, then the rational exponent is the way to go. But if you're kind of in this camp where you kind of like the idea of inverse operations and you're okay with that, then this is another strategy. So the moral of the story here is there's lots of ways to go. We can use this property of roots, and we can use that to our advantage and group things the way we want. But we can also always change things to rational exponents to simplify, and sometimes that's easier for people. So that should give you a pretty good head start on simplifying radical expressions part 2. Now the back of this assignment we kind of decided to cancel. We are going to talk about dividing radicals, but there's a kind of an extra piece that I wanted to talk about when we do that. So we'll come back to this, not this exact assignment, but this concept. And for this homework assignment, just do through 20 here. All right, hope that helped, and thank you so much for watching. See you in class, hopefully.